We've got a 1,200 kilogram car, and it's put in neutral, and it rolls from rest down a 30-meter hill in 6 seconds. And we are asked, what is the net external force that acts on the car? We're going to do this problem the way we do all of our problems. Start with a picture. So we're going to draw the hill. We're going to draw a car on the hill. Apparently it's a pretty steep hill. And we're going to label any distances that we know in our picture. So we've got a 30-meter hill. So this distance from here to here is 30 meters. Or list our givens anyways. So we know we've got a 1,200 kilogram car. Well, that is the mass of the car. So the mass of the car is 1,200 kilograms. It is put in neutral and rolls from rest down a 30-meter hill in 6 seconds. From rest, we got to remember that from before. It's starting with a velocity of 0. So from rest means the initial velocity is 0 meters per second. Down a 30-meter hill, okay, so that's this distance. I'm going to call that x. In 6 seconds. We've got a time. And the question is, what is the net external force that acts on the car? So we're trying to find the net external force, the net force acting on the car. Okay, well, look at our equation sheet, and we see the net force is equal to the mass multiplied by the acceleration. Well, I know the mass. Excellent. However, look at my givens. None of these is the acceleration. So I need to find the acceleration. Well, how am I going to find the acceleration of this car? Well, to do that, let's go back to chapter 2 when we learned about linear motion. Let's look at some of the equations. So let's look at our equations. Well, it's not traveling at a constant velocity, it's accelerating. So we can look at this equation. Final velocity equals initial plus acceleration times time. We want to find the acceleration. We know the time, we know the initial. We do not know the final. That equation will not work. We know how far it rolled. We know the initial. We know the time. We're trying to find the acceleration. We know the time again. This is the equation that we could use. So let's go ahead and use that equation. So delta x equals vi delta t plus 1/2 a delta t squared. Go ahead and substitute in, well, x is 30 meters, the initial velocity is 0, the time is 6, we don't know the acceleration, that's what we're trying to find, time is 6. Simplify this, 0 times 6 is 0, 6 squared is 36. 1/2 of 36 is 18. And 30 divided by 18 is 1.67 meters per second squared. So now we know our acceleration. Go back, substitute it in to find the net force. So the net force is equal to the mass, 1,200 kilograms, times the acceleration, 1.67. So the net force is 2,000 newtons.